Hey everybody, I am going to take some time to go over the final exam review for you all. So please follow along and I will go over the first half of the problems from the review. Okay, so let's get started here with the first problem. It says to determine the perimeter of the image below. So remember that perimeter is all the sides added up together. 1, 2, 3, 4 sides of a rectangle. So what we're going to do is we're going to add all those sides together. And so we have 3x plus 7y. That's the first side right here. We have the second side over here. That's 5. So we're going to say plus 5. The third side here is another 3x plus 7y, so plus 3x plus 7y. And then the fourth side, the last side here, is another 5 plus 5. So this went from a perimeter problem and turned it into a combining like terms problem, because here, now that we have this equation, all we need to do is combine like terms. So what does it mean to be a like term? Remember, it means that we have the same variable and the same exponent. So in this problem, let's start with the first one. We see a 3x. That's just an x by itself. So is there any other x's that don't have any powers? Yes, this 3x right here. So they're both positive. When I add those together, I get 6x. On to the next one. I have 7y. I look for any other y's. There's another one, 7y. They're both positive, so I add them together. 7y plus 7y makes positive 14y. Finish it up. I have a 5. That's just a number with no variables attached. There's another 5 here, so just another number with no variables attached. I add those together. 5 plus 5 makes positive 10. And so my final answer here is 6x plus 14y plus 10. 6x plus 14y plus 10. How do I know that's my final answer? Because there's no more like terms to combine. Okay, problem number 1 done. Let's move on to problem number 2. So problem number 2 says to describe how the polynomial on the left was simplified to the binomial on the right. So right here, this polynomial, how did we get to this binomial? And so we're just going to describe that in words. For everyone that paid attention to the last problem, it's the same thing. Yes, we have subtraction. And remember, when we have subtraction between two polynomials, we have to distribute the subtraction sign in order to be able to combine and remove the parentheses. So here, let's do that. The first term stays exactly the same, 5y to the third minus 8. And if I distribute the negative sign to the first thing, I get negative 7y to the third. And if I distribute the negative sign to the next thing, a negative times a negative makes a positive, so it'll be plus 13. From there, you can just combine like terms, the y's, y to the third powers, excuse me, and the numbers. And we would get our final answer over here. All right, so let me type those words in. You can write this in any way you want. However, I'll explain it in the way that I just did, and then you can make your own personal edits. So first, we must distribute the negative sign to get rid of the parentheses, then we can combine like terms in order to get our final answer. We need to pause real quick so you can copy that down onto your slides. Feel free to do so, and then start back up and move on to the next one. All right. So on to the next problem. Problem number 3 says, which of the following is equivalent to the expression below? So basically, which of these answer choices is the same as this? You guys should all know by now that when you have a number outside of parentheses, it is the distributive property. And when we distribute terms with variables and numbers, we multiply the numbers and we add exponents. So in this problem, we're going to multiply the numbers of this first one. -3 times +2 is -6. Remember, when there's not an exponent, it's an invisible 1. So there's an invisible 1 right here and an invisible 1 right here. And the rule over here says to add those exponents. So x to the first power times x to the 6th power is x to the 7th power. Now we'll do the multiplication of the last term. -3 times -2 is +6. And then here we have x to the invisible 1. Here we have x to the invisible 1. 1 plus 1 makes x to the 2. And so your answer is this. All right, excellent job. Let's move on to the last one. Describe how the polynomial on the left was simplified to the binomial on the right. So basically, it's the same type of problem. We have a term in front of parentheses and a polynomial inside those parentheses. So we are going to distribute and remember, we multiply the numbers and we add the exponents. And so that's what we want to explain here. And that's all we really have to say in this problem is distribute the x. When doing this, you must multiply the numbers and add the exponents. I'm going to add this little piece for everyone that's watching and say, don't forget about the invisible first power. And then that's just remember that this is right here, an invisible 1. So that's where 1 plus 3 makes 4. X, we don't need to have anything to combine it with here, so they just write next to each other. X times y squared, invisible 1 there, right? And then 2 times x is 2x with the invisible 1 there as well. All right, awesome. So that's the problem set 1, review set 1. And now let's jump over to review set 2. Review set 2 it starts with multiplying binomials. The way we did this in class this year is we did the area model or the box method. So we're going to do that. We put one of the binomials across the top, n minus 4. We put the next binomial across the side, n plus 3. And then we need to fill out the inside. And the inside is the area of each square, which is side times side. So n times n is n squared. N times -4 is -4n. 3 times n is 3n. And 3 times -4 is -12. We're going to write all that out as one equation, but before we do that, we have to remember to look for like terms inside the box. We already mentioned what those are: same variable, same exponent. Most of the time, we'll find our like terms in the diagonals, 3n and -4n. So when I write this out, I'm going to start with the upper left and work down, and I'm going to say n squared. 3n minus 4n is -n, and then minus 12 is -12. N squared minus n minus 12. This one right here. Okay, on to the next problem. It says determine the product of the following binomials. Product just meaning multiply. So even though it's phrased in maybe a slightly different way, it's the same thing. We're going to multiply. Five n minus 2, 4n minus 3, and since the area of each square is side times side, we multiply side times side. 4 times 5 makes 20, n times n makes n squared. 4 times -2 makes -8. There's only one n, nothing to multiply it with here, so we keep that n. 5 times -3 is -15. Again, nothing to multiply the n by, so that stays there. And then -3 times -2 makes +6. Combine our like terms. Again, look for in the diagonals. There they are. And writing this out, I have 20n squared. -15 minus 8 is -23n plus 6. 20n squared minus 23n plus 6. There's your answer there. All right, continuing along. This next question. Oh, let me erase that real quick. So on this next problem, it says Jules is making a quilt and is planning to use 4 different fabrics. She lined them up next to each other as shown below to see if she had enough material. Write a simplified expression to determine the total amount of material Jules currently has. Now, if you look at this, it should look like what we were just doing, area model, right? Side times side. You have 4 different sections. You have 1, 2, 3, 4. Oh, 1, 2, 3, 4 different sections. And how do we find the area of a square or rectangle? Side times side. So we can do the same thing that we've done on the last problems here. 4 times 4 is 16. Y times y is y to the second power. Remember, those are invisible ones, and we add, so 1 plus 1 makes 2. That's where that comes from. 4 times 9 is 36, and then there's just one y, so nothing to multiply with, so it stays like that. 7 times 4 is 28. Again, just one y, so that stays there. And 7 times 9 is 63. Say it again. Diagonals are going to look for my like terms, right? And so write out what we have. We have 16y squared. 36 plus 28 is, what is that, 64? Plus 63. That would be your final answer. All right. All right, so that's the last problem on the first 2 review sets. Keep your eye out for the next video, and I will review the next 2 sets for review. All right, thank you. Have a good day.